started.
Cool. So the summary for these three chapters of 12, 13, and 14, you learn how to plan and build a game with Pygame, including setting backgrounds, managing settings, and controlling game elements. You created moving objects like bullets and alien fleets using loops and updates, handled collisions, and tracked game statistics. You also added interactive features such as play button, mouse event handling, difficulty progression, scoring systems, and different ways to display game information. Now I'm going to go to my VS and then you can start with Alien Invasion.
Okay. Right. So alien underscore invasion at py. So what we've got here is right. We pretty much got a system where we pretty much have like so this system here is the main loop for my game. So this is the main loop for my game, right? Which is called Alien Invasion, right? So the initialization, right, for my game, initialization that you see here, pygame.initialization, then py.displaced caption. So what happens there is it initializes pygame, right? So this loads the game settings from settings.py. So that's what happens. So everything that happens here for my initialization, right, it loads the game from settings.py, right? So for my file here, settings.py initializes there. So hence we imported our function there. So let me step over. Right. Okay. So that's what happens there. So it gets initialized, and then game objects created, play button, instance of your button class, stats, SB ship bullets, and aliens. So that's what happens there. Right. So the alien fleet. So for game function, I got an alien fleet that's been created. So display set caption, play button, game stats, scoreboard. So all of that gets created. Right, so I got a fleet here, right? So what happens here for my game fleet is, right, so for game functions, for my class game functions, right, we create a fleet. So within that fleet, we got settings, screen, ship, and aliens. So we got a main game loop. So we got a while statement, which is true. Then you got gf that check underscore events, right? You got an if statement of if states that game's active. Then we can ship, right? We can do a ship that update, ship game function that update underscore bullets, gf that update underscore aliens, gf that update underscore screen, constantly checks for inputs, right? Check events, updates positions of the ship, bullets and aliens only if the game is active, and refreshes the screen, update screen. I think it's double check, right? So that's pretty much what we have here. So what happens there is, so you got a class, right, which runs the game called run game, initialize Pygame settings and screen objects. Then this makes the play button create an instance to store game statistics in the scoreboard. Right, this sets the background color. Right, makes a ship, a group of bullets, and a group of aliens. Ship equals, so the variable equals to class AI settings, the variable, then screen bullets equals group, and then empty brackets, aliens equal group, empty brackets as well. Create the field of aliens, gf dot create underscore fleet AI settings screen ship aliens. Start the main loop for the game. Got a wow statement. GF check events. So AI settings screen stats SB play button ship aliens bullets if statement stats dot game active ship dot update ship update bullets AI settings screen stats then update screen. So that's what you pretty much have, for a main. So for our main one, which is alien dot underscore evasion, that's what you've got. Over to alien dot py.
Okay, cool. So for alien.py, we've got a class of aliens that are represented. And then there's a self image, and they load the alien image from the image folder. We get its rectangular area used for the positioning. They start each new alien near the top left corner on the screen. Their position is set to one alien's width and one alien height away from the top left corner so it doesn't spawn off screen. They store the alien uh, horizontal position for float, and this allows smoother movement compared to using early integers. And then the fleet direction is one for right and -1 for the left. And then it's updated reactive position based on its float. And then over to bullet.py.
Right, so on bullet.py, what happens is, right, import Pygame, right? So Pygame is pretty much the app that installs, so it pretty much has the library of everything that we need to make sure that our game works. So import Pygame. So from pygame.sprite, right, import sprite. So that's what happens. So you import sprite there. So we got a class, right? And now in our class, it's called bullet, right? So class to manage bullets fired from the ship. So we got a class, right? In that class, we got parameters from within self AI settings, screen, and ship. So create a bullet object at ship's current position. So what we got is a class. So with it, it's called super. So within the class, we got bullet, and then we got self. So these are two parameters that we've got, or actually one, because bullet, is a class, and self is a parameter, then initialization. Self does screen equals screen, so create a bullet rectangle at 0, 0, then set correct position. Self.rect equals pygame.rectangle 0, 0 AI dot settings, bullet underscore width AI settings bullet underscore height. So self dot rect center x equals ship dot rect dot center x. So self dot rect dot top. So this pretty much create a bullet rectangle, right? At so this is pretty much the bullet that's been created. So the shape that the bullet has a rectangle. So this is the rectangle bullet width. AI seems bullet height. Then self direct center x ship.rect.center x self.rect.top ship.rect.top store a decimal value for the bullet's position. Self.y equals float self.rect.y. So that's a class. So you've got, a parameter for a variable, which is color, parameter, which is AI settings, then function bullet color, parameter self variable speed factor, parameter AI settings, then function bullet underscore speed that factor. So same thing here. So you got a method, right? Class, then so you got a method and then you got a parameter self. So this moves it, put it up the screen, update the decimal position of the bullet self dot y is then equal to self dot speed dot underscore factor. So what the minus and equal sign does, the equal helps retain the the value, the original one, but it subtracts from that as well to update the rectangular position. So you've got a parameter, a variable, function self dot y, the def draw bullet. So you've got a method, then you've got a parameter self draw the bullet to the screen, pygame dot draw dot rect self dot screen parameter variable, then a parameter, variable, parameter, then variable, then yeah, over to button.
Cool. So in button.py, um, there's screen boundaries, and you can see what the parameters of self screen, and then they set the dimensions and the styling of the buttons with the parameter of self with the variable of width, and then they've got the color variable, and then the color text variable, and then the font. Right, and they create a rectangle for the button and the center, and center it on the screen. Um, and they prepare the buttons, labels, text once, and then they render the text into an image. And then you can see here it's the parameter of self with the image, and then it's got the variable with font, and then the text color and the button color, and then they get the rectangle um, of the rendered text, and they center the text image inside the button's rectangle, and they fill the button area with a background color. Now you can see the parameter of self screen, and then there's the color of the variable, and then they draw the text image on top of the button with the last parameter. Yeah, and then over to game underscore stats dot py.
Alright, so for like game, so for game underscore stats at py, so you got a class, right, called game stats, right? So this is pretty much like track statistics for alien invasion. Then you got a method, right? So within that method, you got parameters, so self, then AI underscore settings, so that initializes the statistics. Self.ai underscore settings equals AI underscore settings. Self.reset underscore settings start the game in inactive state. Self.game underscore active. So what that does is starts the game in inactive state. So it must equal to false. So that boolean that we have needs to be false in order to start the game in inactive state. Then our parameter itself, our variable which is high score, it needs to equal to 0 so that our high score should never be reset. And then we've got another method which is reset underscore stats, and then we've got self, which is the parameter. Then we've got a parameter which self variable shift left, which equals to parameter which is self variable AI settings. Then we've got a function shift limit. So self parameter score variable equals 0, then parameter self, then variable level equals 1. So what this does is initialize statistics that can change during the game. So the statistics change during it. And then we've got image like PNG. That's what we have. So with our image, right, our game can be worked within that image. And then moving over to scoreboard.
Cool. For scoreboard PY, there's a class of scoreboard. They report and display the scoring information and the initial score-keeping attributes. And you can see with the parameters of self, there's the AI game, the settings and the stats. And then they've got the font settings for rendering the text for the score, the level, and etc. And then they've got the text color and the font. So it's obviously a dark grey text with a default font, size of 48. And they prepare the initial images for the score, high score, level, and lives. You can see here they've got the parameters of self with the, the methods. And then they render the correct score as an image, found score to the nearest 10 for cleaner display. And then they format scores with commas, so 1,000 instead, 1,000 instead of 1,000 flat. Then they render text to an image, and they position the score at the top right corner. They render the high score as an image, and then they render the text to an image. They position the high score center at the top, and then then they render the current level as an image, and then they've got the text rendered in the position just below the score, and then they create a mini ship icon for each life left. And they refresh the image, and then they've got the parameters of self, and then they've got the variables, and then they've got the current score, high score, level, small ship icon, and then that's obviously for the lives left. And then over to settings PY.
Settings PY, so we got a class, right? So this class pretty much stores all the settings for alien invasion. So we've got a method. So within that method, it initializes the game statistic settings. So we've got a parameter which is called self, right? Self has settings. So here's the screen settings. So we pretty much have the parameters, which is self. So the parameter pretty much measures, pretty much measures like pretty much measures the variable width and the variable height, and also the parameter. What it does is it also like it measures the variable its BG color. So this pretty much sets like the tuples and the literal values for the color. So that's what it sets. So we've got ship settings. So we've got the parameter itself, and then we've also got a variable. It's called ship limit. So ship limit equals 3. So what ship limit does is, as was discussed in scoreboard, you've got a certain amount of lives. So ship limit starts us off 3. So that's pretty much the amount of lives that we've got left for our ship. Bullet settings, bullet underscore width equals 3. So we've got parameters and variables, right, for our measurements for our bullet. So the width is going to equal 3. Bullet height is going to be 15. Bullet color 60 by 60 by 60, which is pretty much code for the name of a color. Then bullets allowed 3. So that's the amount of bullets that are allowed to be fired at an interval. So then we've got alien settings. So drop speed 10, right? So that's a drop speed that we've got for like our alien settings. So aliens drop down by like 10. So we've got how quickly the game speeds up. So we've got a parameter, then the variable speed up scale, then 1.1. So that's how increasingly quick the aliens get as we pretty much upscale the levels. How quickly the alien points values increase. So you got a parameter that measures our variable score still equals 1.5. Initialize underscore dynamic underscore settings. So we got a method, right? So this method, what it does, initialize settings that change throughout the game. So you've got parameters and variables, speed factor 1.5, speed factor 3, speed factor 0.3. And then you got scoring, parameter variable equals 50. Fifth direction of 1 represents right. Negative 1 represents left. Self.fleet underscore direction equals 1. Then you got a method increase speed, right? Then the parameter self, increase speed settings and alien point values. Parameter, a variable for each. So you got, ships. So you got a parameter for the speed factor of the ship times equals self that speed up scale. We've also got a variable for bullet, speed factor for bullet and speed factor for alien. And then we got parameter for like variable equals integer self that alien underscore points times self underscore underscore scale over to ship.
For ship PY as a class of ship, when they manage the player's ships, they initialize the ship in the set its start positioning. They've got reference to the main screen, access to the game settings like speed, rectangle representing the screen boundaries, and then they load the ship image and get its rectangle area, and they start each new ship at the bottom center of the screen. They store the ship's exact horizontal position as a float. They're more precise than using just react.x, which is um, and then here the movement flags track whether the ship is moving. These are controlled by key presses in the event loop. They center the ship on the screen using after losing a life, and they reset the position tracker. And they update the ship's position based on movement flags. Move right if the flag is set and ship is not at the right edge, and then move left is if the flag is set and the ship is not at the left edge. And then they update react.x from self.x, and they sync the float position with the react position, and then they draw the ship as its currently as its current location is on the screen. So now I'm done with ship PY, and I think we'll run the game.
Wait, hold on. I still need you to do like the explain game functions. So for game functions, but before I carry on, I'm doing this along with my driver, James O. So James O is my driver. So import, so we need import systems. So from time import sleep. So import Pygame from bullet, import bullet from alien, import alien. So you got a method, right? So in this method, you got an if else statement that pretty much responds to key presses. So if event key is exactly strict equal operator Pygame key right, shift moving right equals true. If event key is strict equal operator left, then the shift moving left equals true. Else if event key is strict equal operator Pygame space, then you're gonna fire the bullets, right? AI setting screen ship bullets. So these are like the parameters that we've got here. Else if event key equals Pygame k underscore q systems dot exit. So you pretty much exit the game. So we've got a method, right? Response. So we've got an if statement, if else statement that responds key releases, right? So if event key equals right, straight equal operator right, then move ship moving right equals false. Same thing at the left, it's gonna equal false. Right, so same thing here. So you can check events, right, with the method. Respond to key presses and mouse events. for event in Pygame dot event dot get if event dot type should equal operator Pygame dot quick systems exit event type should equal operator key down check key down events key up right check key up events. Same thing here for also if event dot type should equal operate pygame dot mouse button down mouse underscore x right mouse underscore y pygame dot mouse get position check play and then you got check play button a new game with the play clicks play so you got an if statement for that then pretty much fire bullets and everything in between. Reset game saying hide mouse cursor, reset the game settings, and we got pretty much got parameters and variables for all. Reset the scoreboard images, import the list of aliens and bullets, recreate a new fleet and send the ship, fire bullet, update screen, redraw all bullets. So you got a for loop for that. Draw the screen, function for that, show the play button if the game's inactive, if statement for that, import pygame function, we got a function for that, we got a function for this which update bullets, position of bullets and get rid of old bullets, bullets that update for get rid of bullets have disappeared, for loop for that, then if statement for that. So if bullet reg that button greater than equal to 0 bullets that remove bullet and then yeah we pretty much got methods right for our flag edges. So pretty much what James described. So the rest of the functions pretty much what James described. And then I've also got an environment. So for my images, I got a BMP for each. So for my alien, I got a BMP for that. Then for ship, I got a BMP for that as well. Then for the actual game, I got the PNG, right? So in regards to like the game functionality, James, you can on your side you can pretty much run the game there.
Okay, cool.
Then I'll run it on my side as well. But you
Okay,
start with the explanation for your game, then I'll do it for mine.
okay.
Yeah.
So we're gonna run it in the integrated terminal here. So we'll just Python. Oh no. Just type here Python space and then alien the file name underscore invasion dot py and then enter and then it's gonna run to play the game. Just if I put it like this then you can see the ships and then there's the score on the side here and then if I shoot it then you can see the bullets coming up and then the score in the middle. And you can also see that the aliens are busy moving down towards the lower of my screen. And they are moving right and left. And every time you hit one, you get a point.
Yeah.
And then that's the game. So then you can explain yours now.
So for my game functionality, I'll explain it now in regards to the way that my game works. So I got the play button. So I press play, right? As you can see on my taskbar, my VS Code, you can't see my ship, but on my taskbar you can. So as you can see here, it's moving slowly at first, right? So for every ship that I shoot down, I get 50 more points. So I'm on level 1, right? So as you can see here, the aliens are going down, but they're moving left to right, to left to right. So that's what's happening. So as you can see here, the game function, the game pattern is pretty much being upgraded in that manner. Uh,
You done?
no, not yet, James. Still on level one. So as you can see here, as you can see the functionality. So as you can see here, the bullets get fired in intervals. Right, remember the settings that I said. So the bullets get fired every 3 times. So as you can see here, I've got like 1,300 points. And then as soon as I'm done with this row of like aliens to shoot down, I pretty much go up to the next level. Right, so just need to shoot down the last two and then I'll move on to the next one. Then yeah. So as you can see here, the game functions increased in speed in the way that the aliens are going down. And then on my top left, you can see the amount of ships that I've got left. So by 1.1, the speed of the game in regards to like the aliens has increased, as you can see here. So yeah, that's pretty much it. And then as soon as I press Q, I quit the game. So yeah, that's how you play the game. So yeah, I mean that's it. James and I pretty much explained the game.
Cool. I'm gonna stop recording now.
Yeah. So thank you very much, and thank you, James, for driving my video. And take care. Thanks. So I'm gonna
Awesome.
stop. Thank you. Bless.
Cool, man. That was easy.